Okay, so I'm going to work through problem 1.19 out of Taylor's mechanics textbook. It's a pretty straightforward problem to prove this identity, but let's go ahead and work through it because it is a 2-star problem. So first off, we have to use our product rule. So derivative of the first is just a dot, dotted with v cross r, plus a times the derivative of v cross r. So we have to do a second product rule. So this is that first term plus a times v dot cross r plus v cross r dot. Once again, using a product rule since we're multiplying two vector functions together. And I'm just going to distribute here. I'm going to distribute that a term in. So we have, and this is dotted with v dot cross r plus a v cross r dot. Okay. All right. So let's just start looking at each term. So this second term, what we want to know is that v dot is a. It's the acceleration. So a cross r is going to give us a vector which is mutually orthogonal to both a and r. So whatever that vector is, it's orthogonal to a, and then we're going to take a dot product of a. So if you take a dot product between two orthogonal vectors, it's going to be just 0. Okay? So that term is not something to worry about here. That's r dot. And this one, r dot is just v. So once again, we're going to take the cross product v cross v, which again is 0. And sometimes I like to think of our if you cross two vectors, of course, think of them as the sine, the magnitude of the two vectors times the sine of the angle between the two vectors. Well, what's the angle between two of the same vectors? It's of course 0, and sine of 0 is 0. Okay? So that's essentially what we're doing there. And then, of course, you could say the same thing with the dot product, which is going to be cosine of the angle between them. And in this first term here, I guess suppose, since we know that the velocity dot is the acceleration, then we're going to be taking the dot product of something that will yield us of cosine 90 degrees. So that's why that term goes to 0. And we're left with just a dot, or the time derivative of a, dotted v cross r, which is what we wanted to show. So hopefully that helped. If you want to see more problems like this, please like and subscribe. If you'd like to suggest a problem for me to work through, either this textbook or a different one, join my Discord and let me know, or leave a comment.